Hello everyone, myself Kiran Chudasama and my partners name are Manish Patel and Prishti Shaha. Here we are presenting our project, Design and Analysis of a Hybrid Power System for Natuashish, Labrador. Here is the introduction. Most of remote settlements depend on fossil fuel, especially on diesel, for the generation of the power. Natuashish Island also get its electricity from the diesel generation. This dependency comes with a lot of drawbacks such as expensive gasoline prices, harm to the environment, logistical challenges in the getting fuel. So our main goal of this project is to create a hybrid electric system for this island. The aim of this study is to evaluate the viability of the hybrid power system. We completed modeling and optimizing the hybrid system using Homer. This software makes it possible to simulate a very complicated hybrid energy system. Also, we made a hybrid system in MATLAB Simulink that help us to understand the prototype output of the system. Data acquisition. There are 4 diesel generators on the site of the Natuashish. Total load capacity of the site is 3966 kilowatt and peak is 2053.73 kilowatt. NL Hydro provided us load data. NASA's surface solar radiation data provided the solar GHI and wind speed data. The site annual diesel consumption is 27,15,586 liters in year 2020-22. Also, NL Hydro and we noticed that 0.143 Canadian dollars per kilowatt hour is charged to community.
In this slide, we will discuss the methodology of our project. At first, we use Homer software to ensure the accuracy of the system. We collect load data from NL Hydro and then we import the temperature and wind data and solar GHI data from Homer software. We design this hybrid system using solar PV panel, wind turbine, a battery storage and a diesel generator. Then we select the costs of those all components and we review our result and the economic evolution. Here we have the aim to gain 70% power from renewable energy and 30% power from diesel generator. The main component of this system is generator, solar PV, wind turbine, battery storage and converter. We choose this generator because this generator is reliable and consistent backup for power. Despite our focus on renewable, having a diesel generator ensures a stable energy supply during periods of low renewable energy generation. We choose these solar PV panels for their high efficiency and durability. Here, this panel have a strong performance record and are well suited for capturing solar energy in this island climate. We choose this wind turbine because it offers a good balance between capacity and efficiency. It complements the solar PV by generating energy when solar resources are insufficient, especially during cloudy or low light conditions. We choose battery storage because we need because those batteries have high capacity along long life cycle. Battery storage is crucial for storing excess energy generated from solar and wind sources. And for converting DC power from the solar system and the battery power to the grid, we need a converter. Here we can see the simulation results. The power generated by the hybrid system mainly is solar, that is 56% of the total generation, and diesel generation is 0.045%, and wind turbine generation is 43.8% of total generation, and total generation is 100%. The system cost, the net present cost is nearly 18 million. The fuel consumption is 3,311 liter per year. So we can say that the pollution is also decreased by the for this hybrid system, because it's mainly renewable energy. And the result shows that our hybrid system not only meets the energy needs of Natuashish island, but also significantly reduces diesel fuel consumption and carbon dioxide emissions, making it a sustainable and cost-effective solution. Next slide will be continued by Manish.
Thank you, Bristi, for your contribution to the presentation. Now I would like to give some focus on the MATLAB Simulink modeling. So most of the designing part of the MATLAB modeling is depend on the diesel generator design, PV array block settlement, and set the parameters for the given all the PV array DC converter over there, including wind turbine blocks and configuration of its own parameters, and also battery backup system with the converter. And we have three-phase VI measurement blocks are also over there for monitoring the output of the various component and the load. Lastly, we add the three-phase load block over there for the monitoring of the load. The results from economical and emission outcomes of the systems are very surprisingly very good, where the overall system cost is 18.8 million Canadian dollar, while the capital cost is 11.3 million Canadian dollars, where the maintenance cost is 5,76,296 Canadian dollar for 25 years. So the system is providing us the per kilowatt electricity on the 0.153 Canadian dollar, which is very nearer to the charge, which is now charged to the community by NL Hydro, and it's very constant value for the next 25 years. So we can assume that what is the system's benefit over there. By establishing this system, community will get continue benefits in the terms of financial charges. Also, CO2 emission balance is very good over there. According to the software simulation result, the significant amount of CO2 is reducing, as the previously the huge amount of diesels are burned for the power generation. Now total 22.8 tons CO2 emission is replaced for the 30-year cycles, and only 8,755 kg per year emission of CO2 is emitted by the system. On the ideally, the diesel usage of 3,311 liters per year burned by the diesel generators, and the system supports country's sustainability goal. Just because of this, we can understand how this system is very economically and environmentally sustainable for this small island. So many research has been done by the researchers, and we are also recommending some recommendation for this type of system. Like we can say that we have the maybe we have the sophisticated control techniques by using this type of power electronics, and in maybe in future so many data will be there for the site, and we can easily implement our system by doing some other techniques like changing the renewable energy outputs and varying the load necessities. Like now people are adopting the DC based load device in the terms of home appliances and all that thing. So maybe in future the system may be implemented at the very good level. And also additionally we can say that the source of renewable energy may be changed in the future, like small hydro or biomass, or might be improve the resiliency of diversity of the energy mix. So this type of approaches maybe give us a very good result in future for development, and this type of system may be more optimized by doing this type of modeling and simulation by this type of softwares, which is very useful to develop hybrid systems for small communities as well as for the large communities. We can say this type of development will be make an positive impact on the global platform, and maybe larger communities will be also accept this type of approaches, and by together we can easily achieve our sustainability worldwide goal. On the final stage of our presentation, I would like to express my uh, conclusion report over there, like hybrid electric system development for the Natuashish Island, which is very successful integration of the renewable energy sources, and we are very thankful to the professors and our supervisor for giving us continuous guideline for the project. Also, conventional diesel power system is not achieving this type of performance at the good level, but with the hybrid power system, existing one generator is enough for this type of remote location, and we have proven by this simulation on the Homer Pro. The combination of Homer Pro and MATLAB Simulink has made a positive impact on the designing and optimizing the system, and the future development can be focused on the adaptive control, expanded renewable integration, and broader scalability of the enhance the system benefits and promoting the sustainability energy solution in the similar context. We can say the techno-economical studies made be possible by this type of instrumentation allow for through the determination of most economical and effective system architect. So this type of uh, hybrid power system and this type of renewable goals we can achieve in the nearer future, and we can easily achieve the worldwide sustainability goal very easily. Thank you very much for this presentation.